Welcome to the viewers. Now we prove the equivalence of the operators del x is equal to del z plus del z bar and del y, that will be I into del z minus del z bar, where z equals to x plus iy and z bar denotes as usual x minus iy. This is the operators, and in many ways in complex analysis we using this type of result, and this is very much useful operators. Now we prove how these things happen, why this will come, and just keep watching what happens. Let's watch how these things happen. Now for the part of proof, if phi be any continuously differentiable function, then at first we are going in this way, del phi del x, and that will be using by chain rule, del phi del z del x plus del phi del z bar, that is z in terms of using the chain rule in terms of z and z bar, del z bar del x. And now using this rule, if we are using z equals to x plus iy, then certainly it will be del phi del z plus it will be del phi del z bar. Why these things happen? Because z equals to x plus iy, then del z del x, that will be 1, and if we consider z bar equals to x minus iy, then if we consider as del z bar del x, that also 1. So in this way this one result multiply 1, so that will be happen. Next, we are using this in this way, del phi del x, that will be del z del bar z of phi, and that is, we can say, that is del x, that will be equal to del phi del z bar, and we prove this first part of this result. And now we are going for this another part of proof, that is proof of the first part, result 1, that will be proved. For the next proof of part 2, that is a part 2 proof, if we consider it as part 2. And now here similar condition, directly we write del phi del y, and it will be using the chain rule, that is del phi del z into del z del y plus del phi del z bar del z bar del y. And now we are using, that is del phi del z, here it will be simply I, and del phi del z bar, it will be as minus I, as z equals to x plus iy, so del z del y is equal to I, and del z bar del y, that will be certainly z bar equals to x minus iy. so it will be minus of I simply. I transform to minus of I and we are substituting this result. So it will be I of del phi del z minus del phi del z bar. Therefore, comparing these two, we can easily put as is earlier one, del y, that will be equals to I into del z minus del z bar. In this way we prove this equivalence operator. Result, there is a very much useful result in complex variable. We end our discussions here. If you like this video, like it, share it, and don't forget to subscribe to the channel. Thanks for watching.